Here we're going to be dividing rational expressions, which is pretty similar to multiplying rational expressions, because if you remember, dividing fractions is the same thing as multiplying the second fraction by the reciprocal. So that's what we're going to do. We're going to actually change this to a multiplication of rational expressions problem by flipping this to the reciprocal and changing that sign to multiplication. So let's go ahead and rewrite that first. We're going to have x cubed minus 9x over x squared minus 5x. I'm changing this sign to multiplication, and again I'm going to write the reciprocal of the above fraction. So I'm going to have x squared plus x minus 30 at the top and x squared minus 9 at the bottom. Now I'm going to just continue this problem just like the multiplication of rational expressions by factoring as much as possible and then canceling. So let's see. The numerator here, I see it has a GCF of x, and it'll be left with x squared minus 9. I see that I can keep factoring that to get x, and then x minus 3 and x plus 3, because this is the difference of squares. So in the denominator here, I can see there's a GCF of x, and I'll be left with x minus 5. Multiplication sign. My numerator here is a simple trinomial. I'm going to have x and x. I'm going to bring down my plus sign. A positive times a negative is a negative. And then factors of 30. I got 1 and 30, 2 and 15, 3 and 10, and 5 and 6. But since these are different, I'm looking for something that's going to subtract to give me 1. Do you see anything that's going to subtract to give me 1? Yes, I'm going to use 6 and 5. I always write the biggest one first. The denominator here is the difference of squares. 1 plus, 1 minus. The square root of 9 is 3. And now I'm going to begin looking for items that I can cancel. So I can see right away those x's cancel. This 5, x minus 5 cancels with that x minus 5, x minus 3, x minus 3, x plus 3, x plus 3. The only thing left is the x plus 6 in the numerator, which we know is just x plus 6. Okay, to divide this rational expression, again, first we're going to rewrite it so that it's multiplying a rational expression. So we are going to flip this to the reciprocal. So I'm just rewriting the problem. Changing this to multiplication, and I'm going to write the reciprocal. Once I do that, I'm going to start looking for things that I can factor, and I can see that we're going to have a couple different things we need to do. So let's just kind of take them one thing at a time. I got a numerator and a denominator, a numerator and a denominator, and I'm just labeling it because there really is going to be quite a bit of work. So I can see, let's work on number 1 first. 3x squared minus 13x plus 4. This is a trinomial just like the ones we were working earlier, except this one's a little bigger because there's more possibilities. Their coefficient here is 3. So what I'm going to do is something called the square root method, aka the Colombian method, and I'm going to take this 3 and I'm going to multiply it by itself and the last term. So I'm going to get a new trinomial. Okay. Now from here, I'm going to go ahead and write my 2 sets of parentheses just like I did for the easier trinomials. The square root of 9x squared is 3x and 3x. I'm going to do my signs just like I did the other ones. I'm going to bring this first one down, and a negative times a positive is a negative. I'm going to list all my factors of 12 just like I did before. I have 1 and 12, 2 and 6, and 3 and 4. Since these are the same, I want to look for something that adds to give me 13, which in this case is going to be 12 and 1. And since I changed the problem in the beginning by multiplying by 3, I'm going to go ahead and divide out any common factors, which should be 3 as well. I can see 3 and 12 have a 3 in common. 3x and 1 have nothing in common, which essentially means they have a 1. So my final factored answer for my numerator is going to be x minus 4 and 3x minus 1. Now obviously that is just the answer for this numerator. So what I'm going to do here, since this problem is a little bit long, I'm going to kind of set up my answer, my final answer over here. okay, from factoring. I'm going to say that numerator broke down into x minus 4 and 3x minus 1. Okay? Now let's work out number 2. Number 2 here. So number 2, and I'm going to just go straight to the answer, is the difference of squares. So I'm going to get here x plus 4 and x minus 4. So here I have factored the numerator and I have factored the denominator. I still have this one over here that I need to worry about. So these are pretty simple. In the top I have a common factor of 2. So when I take out that 2, I'm left with x plus 4. In the denominator, I see that they have a common factor of 9. So I'm left with 3x minus 1. Now I'm just going to begin looking for things that I can cancel. I can see that I have a x minus 4 and an x minus 4, 3x minus 1, 3x minus 1, x plus 4, x plus 4. The only thing that's left is 2 over 9. And that cannot be simplified, so that will be my final answer. Again, to divide this rational expression, we want to rewrite this properly by 1, changing this to multiplication and writing the reciprocal of this. I'm also going to put this in order from greatest to least as far as my order goes. You always want the x term first and the constant written last. So when I rewrite this, I am going to write a negative 2x plus 18 because that's proper. 7x squared minus 77x. I'm going to change this to multiplication, and then this is going to be the reciprocal. Okay? Now from there, I'm going to begin looking for things that I can factor. In my numerator here, I'm going to take out the negative 2, which is going to leave me with x minus 9. In my denominator here, I see that they have a 7x in common, which means I'm going to be left with x minus 11 times 7x I'm going to leave alone. I can see that in my denominator here, I have a 2 in common, and that's going to leave me with x squared minus 81. I can actually keep factoring x squared minus 81 because that is the difference of squares. So that is going to break down, and I'm just going to rewrite everything. So I'm going to have negative 2, x minus 9, 7x, x minus 11 times 7x. This is going to be 2x minus 9 and x plus 9. Okay, now I'm just going to look for items that I can cancel. I can cancel the 2's, okay, but this means that this is negative 1 still, okay. I can cancel the 7x's. I can cancel the x minus 9's. So what's really left here is a negative 1 in the numerator, and in the denominator I have x minus 11 and x plus 9. If you want to, you can put it back together by foiling, but I would just leave it like this. Okay, to divide this rational expression, we're going to change it to a multiplication problem by writing the reciprocal of that second fraction there. So I'm going to have x cubed plus 1, x squared minus 5x. This is going to change to multiplication, and I'm going to write the reciprocal. Now I'm going to begin looking for things that I can factor, and right away I see that the first numerator here is something we call the sum of cubes. So I'm just giving myself some space because it is a little bit long. Now the sum of cubes breaks down a certain way. Okay, this is the definition of a sum of cubes. So what I'm going to do is I'm going to figure out what is A and what is B. The cube of x cubed, or the cube root of x cubed, is x. So A is going to equal x. And the cube root of 1 is just 1. So I'm going to use this A and this B, x and 1, to fill in the rest of this definition. And that is going to be x cubed plus 1 factored. Okay, so I'm going to get x plus 1, then I'm going to get x squared minus a 1x, which is just x, plus b squared, which is just 1b b squared is just 1. So that is this numerator fully factored. Now I'm going to move to this denominator. I can see it has a common factor of x, so when I take the x out, I'm left with x minus 5. I'm going to move on to the second fraction. I can see that the numerator cannot be broken down any further, and x squared minus 1 is actually the difference of squares. So it's going to be x and x plus 1 and minus 1. Now that you've factored everything as much as possible, you can look for things you can cancel. I can see that I'll be left with that can cancel and this can cancel, this and this cancels, and I'm left with a couple things. But right away I noticed that there's a trinomial here that I didn't try to factor. Well, I know what it is. It's x squared minus 1 already. I already know what it is. Well, I don't know what it is. So what I'm going to have to do here is I'm going to have to put everything together. So I'm going to have x squared minus x plus 1. And the stuff that's left, I got x and x minus 1. But I don't want to say that I'm all the way finished yet because I think I can factor this trinomial. So let's try. If it's an easy trinomial, it would break down as to x and x. First sign comes down as a minus. Negative times a positive is a negative. And the only factors of 1 are 1. So obviously, if I put this here, this is not going to give me this result. So I cannot factor that any further, and this will be considered my final answer.